This is part 2 of my interview with Rosenberg. The other parts will be in the description of this episode. Alongside having worked at NASA and developing the world's first AR system, Lewis also started Unanimous AI, which built a software that allows people to come to decisions together. This comes from the idea in nature known as swarm intelligence. Instead of polling, groups of people come together in a real-time, dynamic feedback loop system with artificial intelligence to converge on an optimized decision or solution. And we'll talk about what all that means. In the past, this approach has successfully predicted Oscar winnings better than any individual movie rating agency. It's also improved the diagnosis of conditions in X-ray exams, and even predicted sport event outcomes better than any expert. If you're new to the Utopian podcast, welcome. Please consider following the UPod on whichever platform you're using and sharing it with your friends. Don't forget to check out my website at theutopian.blog for more. So you're also known for founding a company called Unanimous AI, which aims to amplify the intelligence of human groups by mixing artificial intelligence with this idea in biology called swarm intelligence. So could you explain that idea, swarm intelligence, and how does Unanimous AI provide value with this idea?
Right. So I'll say from the start that Unanimous AI is a really different type of AI company. And you know, the premise of most artificial intelligence work is to replace people with algorithms. Most AI is processing huge sets of data and allowing automated decisions that can replace what a human would normally do. And Unanimous AI were really founded on a very different premise, which is that, hey, people are actually really smart and have massive amounts of knowledge and wisdom and intelligence and insight in their heads. And you know, the human database is actually richer than these static databases that that traditional AI processes. And so our approach is to say, well, how can we use AI to make people smarter by connecting people together rather than replace people? And the inspiration for this idea of, well, can we make people smarter by connecting them together comes from nature. And that's where we get to swarm intelligence. So it turns out that evolution has been looking at this issue for hundreds of millions of years, which is, let's say you have a large population, and that population all has slightly different views of the world, slightly different experiences, slightly different temperaments. Can you combine all their insights and allow them to be smarter together than they are alone? And it turns out that many different species have evolved methods of doing that. You can think of a school of fish. A school of fish could have thousands of members. They all can see a slightly different view of the world. They have slightly different experiences, slightly different personality, and yet they work together as a superorganism to make decisions. A school acts as if it's a single organism that can navigate the ocean and survive. And they do that through what biologists call swarm intelligence. The same exact principle happens in swarms of bees, which is where the name swarm intelligence comes from, flocks of birds. It's across many, many different species. And the difference, the way that it happens is that these groups form systems. They form systems with feedback loops. In the case of schools of fish, they can detect little vibrations in the water around them, which is how they're essentially communicating with the other fish. And they're all working as a feedback loop to make decisions.
Yeah, it's really cool how you're combining sort of the intuitions and the social dynamics of humans with the data filtering and computational abilities of AI. And I mean, that's certainly a powerful combination. But how exactly does the AI tie into this? Like, does it just give a it analyzes all the data of like where everybody was pulling and then gives like a confidence measure at the end after the swarm event has taken place? Or does it actually sway the group towards one option or the other? Like, how does that actually work?
To understand it, the key thing is to realize it's a real-time system. Everything's happening in real time. And so the interface that we have is really about getting people to behave, right? So you can give somebody a survey and just say, who do you think is going to win this political election? And they could just give you a piece of data on a survey, and you really don't know very much. And that's really how most human data is collected. They give you this one data point. I think that so-and-so is going to win this election, or I think so-and-so is this team's going to win the Super Bowl. And then you can do machine learning on that. You really, you're starting with bad data, and you really don't have much you can do with it. A swarm is really a different thing. A swarm is, and a lot of people say it kind of looks to them almost like a Ouija board, because there's a little glass puck, and each person can control a magnet. It's just a graphical magnet, and they can pull on they can use their mouse, their touch screen, or their phone, and they can pull on the puck, and they're trying to move the whole swarm to an answer. The key thing is that it's all happening in real time. So a question appears, who's going to win the Super Bowl? Everybody reacts. You could have 50 people in this swarm. They're all start pulling with their magnets, and the AI is watching that happen. So it's looking at everybody's behavior, and it's determining, oh, the swarm should move in this direction. But as soon as the swarm starts moving, everybody changes their behavior. They react. And so 200 milliseconds after the AI looked at everybody's behavior, people start changing their behavior. And so the people change their behavior, and then the AI looks at their changing behavior to understand who has high confidence, who has low confidence. It's assessing people's conviction in real time. And so the people act, the AI starts to move the swarm, the people react, the AI reacts to that, and so you have this feedback loop where the AI and the people converge together on a path for the swarm that is an optimized combination of their conviction and their confidence. It's evoking from people, who are the people that have, knowledge and wisdom and insight that they have high confidence in, who are people who might have some confidence in some aspects of the question, but not others. And so it allows the group to converge on solutions that are really a good combination. And it's because it's a feedback loop that's happening in real time. It's not the humans hand over a set of data, and then the AI does machine learning on it and says, here's what we think that the best answer is. And if a swarm of bees can make decisions and be significantly smarter than any individual bee, couldn't humans do? Why can't we humans do that? We didn't evolve to do it, but we've put satellites in orbit and put cell phones in everybody's pocket, and we have the ability to connect everybody. Can we use that to make groups of people smarter? And so we founded Unanimous AI to say, can we connect groups of people using AI algorithms that are modeled on the swarm intelligence methods and allow them to make decisions together? And would they get smarter? It was a guess. Like, it works in nature, it should work with people. And it turns out it does work. When we allow groups of people to come together in these real-time systems, they get significantly smarter. And so to prove that, we've partnered with a lot of different major universities to just run really rigorous tests just to say, can we show rigorously that groups of people get smarter? We ran a test with Oxford University looking at just groups of sports fans. And part of the reason we use sports fans is that when you're trying to prove a group is smart, you want to give them a test where they don't know the answer, they can't look up the answer, and then we can know the results the next day. And so predicting sporting events is a great test. And so we had groups of sports fans who were fans of English Premier Soccer. And we had them forecast the results of 50 consecutive soccer games over 5 straight weeks. And they would either just do it alone as individuals, they would do it as a group by taking a vote, a majority vote, or they would work together in our software platform called Swarm, where they would form a system and converge together on a solution. And when they worked together as a swarm, they were 30% more accurate in predicting the outcome of these soccer games than if they did it using other methods. And in fact, they were so accurate, they outperformed the Vegas betting markets. We published a study with Stanford University that went the other direction, said, let's look at the most highly skilled people. Can we take really, really skilled people and make them smarter? And so we had a research study we published with Stanford Medical School saying, let's look at groups of doctors, and can we allow them to make better diagnoses as a swarm as compared to making diagnoses as individuals or just by taking a vote. And so it was small groups of radiologists. It was just 4 or 5 radiologists. An X-ray would pop up on their screen, and then they would go into our swarm software and they would diagnose the X-ray together, either by taking a vote or by working as a swarm. And when they worked together as a swarm, they reduced their diagnostic errors by 36% as compared to just taking a vote. And again, it shows that nature works. Forming these real-time systems makes groups of people smarter, allows us to combine their knowledge and wisdom and insight so they can converge on solutions accurately.
And what about scalability? Like, does Swarm AI become more accurate or powerful in some way with more participants, or is there some sort of S-curve underlying here where there's like an ideal number of participants or too few? And perhaps are other decision-making methods better for certain group sizes?
So it's a great question. And it's one that that really surprised us, because I had when I started working on this, I thought, well, it probably will get smarter and smarter and smarter with larger and larger and larger groups. Even though in nature, it's actually a little bit different. So in honeybees, for example, a honeybee colony can have about 10,000 bees, and they work together in swarms to make decisions, but usually it's just 300 or 400 bees out of the 10,000 that work together to make the decision. And that should have given us a clue that maybe there's diminishing returns when you get to larger and larger groups. And so when we first started working with Swarm, we started with groups about 50 people. We thought, if we go up to 100 people, 200 people, 500 people, 1,000 people, it will get smarter and smarter and smarter. It turns out that between 50 and 100 people, you kind of max out on the value of adding more people. You just get slightly greater intelligence. And the other thing, so that really surprised us. So if for a lot of the swarms we do to, to predict events, we'll use about 50 people, and it works really well. If you have a group, and that's really if you're using like a diverse group with a lot of where you maybe don't know that much about the people. If you really know about the people, they're meaning they are experts, and they're experts in their field, like what we did with Stanford with radiologists. They were able to get very 30% amplification with just 5 people. So even like very small groups work. We've seen people do financial forecasting with analysts, really accurate with about 10 to 12 people. One of our customers is actually the United Nations. One of the most interesting customers, they use Swarm to predict famines around the world. And so it's interesting. They have groups of experts that are spread around the world that will look at different countries. They'll say, is there going to be a food insecurity in Haiti over the next 18 months? And they'll have 20 people come into Swarm, and those people might be logging in from 20 different countries, and some of them will be experts on the weather conditions, and some will be experts on the political conditions, and some will be experts on the economic conditions. And so they all have different perspectives, which is really interesting. So they can come in and they can work together and converge on an answer that is the best forecast they can make based on the combined knowledge that they have. A really interesting example is you can compare to, say, traditional polling. Like traditional polling, you need to go to thousands and thousands of people, and you still have polls fail. And last year we were asked by a number of journalists to predict all the battleground states for the presidential election, the U.S. presidential election. And so we brought together just 50 voters from around, spread around the country. They came into Swarm, and we had them predict the battleground states. And major polling companies would ask questions to thousands and thousands of voters. The polling companies got most of the battleground states wrong. It was really a lot of errors in polling. We had 10 out of 11 of the battleground states correct. In fact, the Wall Street Journal wrote an article about it because we had the most accurate predictions, and we only used 50 people. We used 50 voters. And the reason for that is that we treat people differently. And this is a subtle point. In a survey, you treat people as a data point. You say, hey, I'm giving you a survey. Who do you think is going to win this state? It's a data point. When somebody comes in and they're part of a swarm, we treat them as a data processor, right? We're saying, we're not asking you what you think, who you're going to vote for. We're asking you to consider the people that you know, your family, what you heard on the radio, all the information that you've collected about this election, and you're going to work together with 50 other people, and you're going to predict who's going to win this election. People are smart, and you guys can converge based on all your knowledge. You all have gaps in your knowledge, but when you work together as a swarm, you're filling in each other's gaps, and you're going to converge on a good forecast. As opposed to just giving somebody a survey in isolation and saying, just tell me a few data points about yourself.
Yeah, and what kind of problems do you see Swarm AI tackling in the years to come?
Yeah, so it works really well for any types of problems where human expertise, human knowledge, human wisdom, human insight comes into play. And so there are certain applications where traditional machine learning is fine. And those are applications where there's some huge amount of data that just doesn't change very much, like predicting the weather, right? Predicting the weather, they're using historical models, massive amounts of data. Yeah, it's changing over time, but it doesn't change that much. But the thing that we found when we work with corporations is they say, oh, well, you can predict the weather with machine learning. We should be able to predict if our clothing is going to sell this holiday season. And so they take historical data about the last few holiday seasons and they say, okay, let's use that data to predict if our new product's going to sell this holiday season. And then they find it doesn't work. And it doesn't work because what they really did was they predicted if their new product was going to sell last holiday season, because that's the data that they had. Because the conditions on the ground change so much in those type of applications. Whereas human beings, we are data collection machines. We're out there in the world. We're continually updating our model of the world. We're listening to the radio, watching TV, talking to people. We have a sense of the sentiment of the public. And so we could bring 12 people together and ask them to forecast if a product's going to sell well in the next holiday season. And they will do better than a machine learning system that has massive amounts of historical data because people are continually updating their knowledge and their wisdom. And the thing that's amazing about people is that the human brain is exceptional at using relatively small amounts of data and extrapolating into the future. Machine learning is actually, traditional machine learning is kind of the opposite. It's great at using huge amounts of data and predicting things that it has seen before. And we actually did a follow-up study with Stanford University with those groups of doctors to say, okay, we've shown that small swarms of doctors can outperform an individual doctor or a group of doctors taking a vote. Let's instead have this swarm compete against the best machine learning system out there in the world. And it turns out that they were equal. They were equal, which was actually pretty amazing because both of them were better than any doctor in the world, but they were equal. But the interesting thing was they were equal in different ways, meaning they both had the same level of accuracy, but they were good at different types of problems. The traditional machine learning system was really good at problems that looked just like things that it had seen before, things that were in its huge database. the humans were really good at things that nobody had ever seen before and extrapolating into the future. And so what we concluded from that study was to say, well, if we built a system that combined the power of both, right, where a traditional AI can process things that look exactly like things that have been seen in the past, but those cases where it didn't look like things that the machine learning thought, we gave it to a swarm of doctors. If we went through that kind of triage process, the combined system could be significantly better than humans or machines alone. And so the point is that there is, people have our strengths. Traditional machine learning has their strengths. If you can identify those strengths, then you can partition problems and have, take advantage of the best of both capabilities.
I hope you enjoyed this episode of the UPod. If you did, please give a like if you're on YouTube and follow the UPod on whichever platform you prefer. That's Spotify, Google Podcasts, or Apple Podcasts. If you want to learn more, go to www.theutopian.blog and join my newsletter. I also share exclusive interview highlights, infographics, and community events which you can join all on my Instagram at the.utopian.blog and on my LinkedIn page, The Utopian. I'm always open to being messaged on any of those platforms if you ever want to get in touch. I really appreciate your support, and I hope to see you next time.